Hey, hi all. Welcome to BRR Knowledge Center. In this session, we are going to talk about what is this garbage collector. Okay, so the .NET, this is one of the component inside of CLR, wherein it controls the memory management when you create a variables or objects during the program execution. So memory management is the main concern for any application, looking at any kind of application, either mobile application or desktop application or web-based application. This is the main concern for every developer, which needs to be, say, continuously looking at the programming, how they are going to write, right? And also how the programming is going to allocate space for the variables and what kind of how much size it is taking while storing your values instead of these variables. So when running an application, memory management is one of the main and important aspect to look at this, memory space and usage, which is going to, takes for your program. So in .NET, CLR has a garbage collector, which executes, right, as part of program execution. And it is the responsible for, reclaiming the memory of no longer using objects, right? So when you talk about the definition, right, uh, memory management, right, is the right main main concern for any application, right? Whether application is Windows or web based, right? In .NET, in .NET, CLR has GC garbage collector that executes as part of our program and responsible responsible for reclaiming the memory for no longer objects, no longer used objects. Suppose I have created, right, class student. Inside of that, I have a variables like student ID and student name. And also I have, right, methods void display student details, right? And for this, I'm getting student object, and then I'm going to display this student information inside of this method. Right line of student details. Okay. Console dot right line of student ID. Okay. Obj dot SID. Similarly, for the student name, I'm going to display student name is S name, right? So looking at this program, let me reduce the size. Okay, looking at this program, so this is the function inside of this, right? And these are the variables have been defined as part of this student class. Now, if you want to access this, right, what you need to do is you need to create, right, object for this student, right, this way. And then you need to assign obj student, right, dot SID equal to some 3387 and obj student dot sname equal to some BR. And after that, what you need to do is student dot, right, display student details of obj student. This way I'm going to pass object to this particular method. If you look at here, I have created, this is value type, this is reference type, and this is again reference type because of class type you are creating it. the student is class, right? So in this case, when you execute a program, the garbage collector will take responsibility to locate, right, the unused objects, and then it will reclaim the memory for other programming variables. That's what the purpose and role of this garbage collector. So garbage collector free the memory for the objects that are no longer referenced and keeps the memory for the future applications. Okay, that means this GC, this garbage collector, right? Free the memory for objects that are no longer referenced, no longer referenced, and keeps the memory for future allocations. If you look at an application, I have different pages. I used one page, right? I just did some functionality and then I go for another page, right? So I'm working on another page, right? But I opened two pages. So looking at the memory, first page related objects also going to be stored in my memory. But I'm not using actually this first page. I was on the second page. I'm now doing some operations on second page. So in this case, another other user is going to execute one of his programs, same system. Then memory is not having sufficient space to execute the second program. Then what this GC is doing is GC will look at this no longer active objects, like in my case, page one objects, and then it will clear those and make memory free for the second program execution. That's what the duty of this particular thing. Okay, look at these advantages of this now this garbage collector, right? First one is allow us to develop an application without having, right, worry to free memory. So as a developer, you no need to worry on allocating memory or freeing up memory, right? Secondly, allocates memory for objects efficiently, right? And the managed heap. So I'm not sure like you guys are aware of what and how memory is creating it. So when you talk about a program, right? Let us say that this is my program. This is my program. So when you execute a program, okay, when you execute a program, okay, it is going to create, right, CIL code, right? What you call common intermediate language or MSAL code, right? And after that, and after that, oops, what happened? It's got stuck up. Oops. So when you execute this program, it is going to create a memory for your code. In this case, this particular stop. What happened? Stuck up. Oops. Getting stuck up here. I'm not sure. Let me try this. Okay. Let me wait for a second. It seems system hangs. It's stuck up with some execution here. Maybe I clicked multiple times on this drawing utilities here, tools. I think let me give some time. So what I'm trying to say about is, so when you execute a program, it is going to create a heap and stack memory. Basically, stack memory contains the reference data type, variable memory usage. And when it comes to reference stores, the reference data type variable space. Of course, the reference data type, right? Values again will get saved into a value type. So when this program start execution, right? So developer as a developer, right? You are not worrying about how memory is going to free up or create. Secondly, it allocates memory objects, right? Efficiently on the managed heap. So in the heap, it is going to efficiently create space for your objects. So, my God. మీరు looking at here, I think you'll be clearly seeing that, right? Code is right executing, it started. Okay. And then it is going to create two type of memories here, stack and heap. Stack holds the value types, right? So in this case, this integer is a value type. Okay, this is value type because integer data type is value type, and this is a reference, right? That means this is a reference data type, and here class also belongs to this reference type. So all these things are going to be stored in this heap memory, right? Only this contains SID because this is value type, but here you will have, right, SNAME and student. Student is a class, right? And also object. Object is again a reference type. So when you're creating and executing this stuff, no need to worry on memory creation because GC will take care of it. Okay. And coming to the third one, reclaiming of memory for no longer used objects and keeps the free memory for future allocations. Okay. GC will reclaim the memory for no longer used objects. Fourth one is provides memory safety by making that an object cannot use the content of another object, right? Provides memory, right? Safety, right? By making sure that an object cannot use the content of another object. That means, suppose I have a student object. Here, the student object is obj student. This obj student is going to be stored here. Let me try one more diagram. Okay. So this is my heap memory. This is my heap memory. Okay. So obj student is one object. Obj student is one object. Correct? This is holding the data like 3387 is student ID, right? And BRR is the student name. Okay. Now when I'm trying to create one more object, student obj1 equal to new of student, okay, obj1 dot SID equal to 3388, right? obj 1 dot s name equal to, right, bhsr. So this object is different and this object is different, right? Both are different objects. Now what it will do is, okay, it will create, right? Let me move to next page. Let me move this to next page. So coming here in my heap memory, right? It is going to create one more object, right? That is called obj1. This is one more object. And this is having memory separately. And here I'll be having this particular object data called student ID is different, that is 3388, and the name is BHSR. So this is different and this is different. It won't share this or this. Okay, this is not going to stay. This is not going to share between the objects. That's what I'm trying to tell about the advantage of a memory safety by making sure that an object cannot use the content of another object. Okay, so coming to this next one, okay, coming to next one is generations in managed heap. So we basically in the garbage collector, we have three generations. We have three generations. One is Gen 0, another one is Gen 1, and last one is Gen 2. What is this Gen 0? This is the youngest generation and contains the newly created object. Contains newly created objects. So generation 0 has short-lived objects. Gen 0 has short-lived objects and collected frequently. Okay. So the objects that survive the generation 0 are promoted to generation 1. That is called a temporary objects. When it comes to generation 1, the generation 1 contains the longer lived objects that are promoted from Gen 0. Okay, the objects that survive the generations 1 are promoted to generation 2 basically. Okay, so basically generation survives, right, as a buffer between short-lived objects and longest lived objects. Coming to this generation 2, this is contains, right, this is contains longest lived objects that are promoted from Gen 1 and collected frequently. So an object, right, at application level that contains static data, which is available for the duration of the process, right? That is what a longest example is an object. Let us say like date formats, I'm going to use it across my application. Whatever date formats I'm going to assign it while my login into the website, those values and object of this date formats are same and required throughout my application process, right? Those are longest lived objects. So an object at application level that contains static data which is available for the duration of the process, right? That is date formats for my case. Okay, so these are different generations we have in garbage collector. So the managed heap is organized into these three generations so that it can handle short-lived and long-lived and longest-lived objects efficiently. So garbage collector first reclaims short-lived objects that occupy a small part of heap. Okay, so let me give you a small diagram to explain more on this. Is this one. If you look at this generations on managed heap, right? So here garbage collector will look at this. These are generation 0 means newly created objects. These are promoted to generations 1. These are promoted to generation 2. So here free memory is showing here. Okay. So now, pause. Looking at generation 0, right? 8, 9, 10 are the newly created objects. And these are 5, 6, 7 or promoted from generation 0. And these are 1, 2, 3 promoted from generation 1. So there are some phases in the garbage collector like marking phase, reallocating phase, compacting phase. Okay. So which basically having a different addresses, right? Based on that, it is going to reclaim the process and free the memory. Okay. So this is something the duties and responsibilities of a memory, right? With a garbage collector. Okay. I hope you understood this garbage collector purpose, right? And advantages of having it this as part of .NET and how this 3 generations are, right? Going to helpful to free the memory for developer, right? Generation 0 and generation 1 and generation 2. Okay. So as I said, this garbage collector basically reclaim the process based on the phase, like marking phase, reallocating phase, right? And compacting phase. That's how it is going to free the space and help the developers to create new objects. Okay. So thanks for listening to this video and please subscribe this channel for more videos. Thank you.